G'day guys, welcome back to my channel. In today's video, as you may have read from the title and the thumbnail, I'm going to be attempting India's toughest mathematics paper. It's the JEE Advanced. I believe it's split into 3 different subjects. You have mathematics, physics and chemistry. I will be attempting the physics paper sometime in the future. Also, if this video helps you in any sort of way, please leave a like, please subscribe. For now, let's go straight into the maths. Mathematics, Section 1. Question 1. Consider only the principal values of the inverse trigonometric functions. The value of this expression over here is... Question 1. First thing I will do in order to solve this is drop a right angle triangle. Just to make things clear with inverse trig and normal trig. Theta up here, we have root 2 goes there, pi, and when we square both sides, take the square root, we get pi squared plus 2. Obviously, we're looking at this over here. We have cos inverse of root 2 upon square root of 2 plus pi squared. Correct? Next step. Looking at this expression here, inverse sine of 2 root 2 pi all upon 2 plus pi squared can also equal to inverse sine of 2 dot pi on root 2 upon 2 dot pi upon root 2 all squared. Correct? When we simplify this part, the bracket, this is the full bracket, simplify this, we get that. Next step, also we can develop is cos inverse of root 2 upon 2 plus pi squared square root equals to tan inverse of pi on root 2. This equals to this. Further then means pi minus 2 tan inverse of pi on root 2 as sine inverse of 2 sine inverse of 2x upon 1 plus x squared equals to pi minus this over here, 2 tan inverse of x, given that x is greater than or equal to 1. And our identity over here, no, therefore then tan inverse of root 2 upon pi equals to cot inverse of pi on root 2. Sorry, it's a root 2 upon pi equals to cot pi on root 2. Therefore, we can sub all of these back into these over here. So this then gives me 3 upon 2. Cos inverse of this is tan inverse pi on root 2 plus 1 on 4 sine inverse is equal to this over here, pi, take a brackets, minus 2 tan inverse of this pi on root 2, correct, plus, we figured this equals to this over here, cot inverse of pi upon root 2. Further simplifying this, we then get 3 upon 2, brackets 3 upon 2 minus 1 upon 4. We have tan inverse pi on root 2, brackets plus pi on 4 plus cot inverse pi on root 2. Further simplifying this, we get tan inverse of pi on root 2 plus cot inverse of pi on root 2. Correct? Plus pi on 4. This then further gives me pi on 2 plus pi on 4, which is 3 pi on 4. This is asking us for 2 decimal places, so we put this in our calculator and we end up getting 2.36. Question 1 done. Let's go on to question 2 now. Question 2. Let alpha be a positive real number. Let f, real to real, and g, alpha infinity to real, be functions defined by f of x, sine pi x upon 12, and g of x, 2 ln of root x minus root a, all upon ln of e to the root x minus e to the root a. Then, the value of limit x approaching positive alpha fg of x is what? Question 2. First thing, let's write g of x down. X equals to g of x. We have limit x approaching positive alpha. We have 2 ln of root x minus root a, or alpha in this case, upon ln of e to the root x minus e to the root alpha. Once we've written that down, we're going to be using the L'Hopital rule. To solve. What is the L'Hopital rule? Let's write it down. We then take out the 2 in front. We have 2 limit x approaching positive alpha. Taking the first derivative of the top and the first derivative of the bottom. Doing that, we get 1 upon root x, brackets, 1 upon root x minus 1 upon root a, or alpha in this case, multiplied by 1 upon 2 root x. Denominator becomes 1 upon e to the root x minus 1 upon e to the root alpha multiplied by 1 upon 2 root x. Correct? Common terms here, they get chopped off, gone. Further simplifying this, we then get 2 upon e to the root x, limiting or limit x approaching positive alpha, we get e to the root x minus e to the root alpha, all upon root x minus that. Next step, 2e to the root x, limit x approaching positive alpha, we get e to the root x multiplied by 1 upon 2 root x minus 0 all upon 1 upon 2 root x minus 0. This all equals to 2. Since limit x approaching positive alpha, f of x equals to f of g of x, f of g of x, as it's asking us over here, f of g of x equals to f of 2, as we're developed over here. We can sub this back into this expression here, f of x. So f of x then equals to f of 2, which is sine pi 2 sine 2 pi on 12, which equals to pi on 6, which equals sine pi on 6, which equals to 1 upon 2. Therefore, 0.5 is our answer for question 2. Now to question 3. Question 3. In a study about a pandemic, data of 900 persons was collected. It was found that, down question 3, 190 person had symptoms of fever. N of F fever is 190. 220 person had symptom of cough. N of C would be 220. 220 person had symptom of breathing problems. N of B equals to 220. 330 person had symptom of fever or cough, or both. Writing this down, N of fever or cough was 330. 350 person had symptoms of cough or breathing problem, or both. N of cough, B would be 350. And N of fever or breathing problems, F U B, equals to 340. Lastly, 30 person had all three symptoms. N of F C B equals to 30. Correct? If a person is chosen randomly from these 900 persons, then the probability that the person has at most one symptom is what? To further understand what this question is asking us, let's draw up a Venn diagram. A Venn diagram will help us understand the question. One, two, three. At most, one symptom. It could either be no symptoms, correct? Could either be this, what we need to find is the intersection points. This, 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 and this. That is what it's asking us. At most, one symptom. In order to do that, first step is we need to figure out the intersection points. Fever, you cough, is 330. In order to find intersection, we know that 330 equals to N of F, which is 190, plus N of C, 220, minus N of F and C. rearrange, we then get n of f c equals to 410 minus 330, which equals to 80. This equals to this. Similarly, let's do for cough or breathing. We know that is going to be 350 equals to cough 190 plus 220 minus n of sorry, not 190, that's going to be 220, my bad. It's going to be 220. 220 plus 220 minus this, and NCB. Rearranging this, we then get 440 minus 350 is 90. This one now, we have 340 equals to 190 plus 220 minus the intersection of B. This then gives me an B equals to this minus this is 70. Not blue, we know is going to be 240 minus 2 multiplied by 30. 30 is all inclusive, which is going to be 180. Therefore, finding the probability we have is 900 minus 180 all upon 900. Gives me 720 all upon 900, which in this case, gone. Further put in the calculator, we should get 0.8 as our final answer. Question 3 done. Let's move on to question number 4. Question 4. Let z be a complex number with non-zero imaginary part if 2 plus 3z plus 4z squared upon 2 minus 3z plus 4z squared is a real number, then the value of modulus squared of z is what? Question 4. First step I will do, let a or alpha be equal to 2 plus 3z plus 4z squared all upon 2 minus 3z plus 4z squared. Further simplifying this to try and make the top equal to bottom, we can rewrite this as 2 minus 3z plus 4z squared plus 6z all upon 2 minus 3z plus 4z squared. This then gives me a plus 6z all upon 2 minus 3z plus 4z squared. Further developing, a equals to the mod a bar. This then gives me z upon z minus 3z plus 4z squared, which equals to z bar upon sorry, that's not z, that's 2. Yeah, 2 minus 3z bar plus 4z bar all squared. Cutting this down, we then get 2 z minus z bar equals to 4 z bar brackets z minus z bar. Coming down, we factor out the 2, we get z minus z bar equals to 2z bar z minus z bar. Correct? Next step, further simplifying this, we then get z minus z bar brackets 1 minus 2 z bar equals to 0. Rearrange and factorize. As z cannot equal to z bar, given from this expression over here, we know that z multiplied by z bar is modulus squared equals to 2.4, which equals to 1 upon 2. Therefore, z all squared equals to 1 upon 2, which is 0.5. Straightforward question. Let's go to question 5 now. Question 5. Let z bar denote the complex conjugate of a complex number z, and let r equal to square root of negative 1. In the set of complex numbers, the number of distinct roots of the equation z bar minus z squared equals to I. Z bar plus z squared is what? Question 5. First thing, let's write it down. Z bar minus z squared equals to I. Z bar plus z squared. Most basic thing, let z equal to x plus iy. Z equals x plus iy, let's sub that into this. We then get x minus iy minus x squared minus y squared plus 2xy equals to I brackets x minus iy plus x squared minus y squared plus 2xy. Further simplifying this, x minus iy minus x squared plus y squared minus 2xy equals to negative y plus ix plus x squared minus y squared I minus 2xy. Collecting like terms, we can split these into two equations. Equation number 1 becomes x minus x squared plus y squared equals to y minus 2xy. It's going to be equation number 1. Equation number 2 becomes the imaginary parts, negative y minus 2x y. So these are real, this is imaginary. X plus x squared minus y squared. Equation number 2. By monitoring both of these equations, most suitable thing to do would be 1 plus 2, equation 1 added onto equation number 2, should then give me negative 4xy equals to 2x. Correct, that gone, that gone. 2x, correct. Therefore, x equals to 0 or y equals to negative 1 upon 2. Or x equals to 0 or y equals to negative 2. Now we're going to sub these back, both of these, separately into equation number 2 sounds suitable. Yeah, equation number 2, we then get negative y equals to negative y squared. Y then equals to 0, 1. 2 solutions for y. Sub this into this. We then get 1 upon 2 plus x equals to x plus x squared minus 1 upon 4. Simplify this further, we get 3 upon 4 plus x equals to x plus x squared. X squared equals to 3 upon 4. X equals to plus minus 3 upon 4. Correct? 4 solutions, therefore number of distinct solutions equals to 4. Question 5 done. Let's go to question 6 now. Question 6, arithmetic progression. Let's look into it. Let L1, L2 all the way up to L100 be consecutive terms of an arithmetic progression with common difference D1, and let W1, W2 all the way up to W100 be consecutive terms of another AP with common difference D2, where D1, D2 equals to 10. For each I, 1, 2 all the way up to 100, let R of I be rectangle with length L of I, width WI, and area A of I. If A51 minus A50 equals to 1000, then the value of A100 minus A90 is what? First thing I would write down is Li di and W1 D2. W1 D2. This is going to be 1, my bad. L1 D1 W1 D2. A 51 minus A of 50 equals to 1000 as I'm given. Hence L51 W51 minus L50 W50 equals to 1000. Right? L1 plus 50 D1 multiplied by W1 plus 50 D2 plus 50 D2 minus L1 plus 49 D1 W1 plus 49 D2 equals to 1000. This developing this over here will help us with this question right here. Next step, let's expand and simplify. We then get L1 W1 plus L1 50 D2 plus W1 50 D1 plus 50 squared D1 D2, 50 squared D1 D2 minus this side now L1 W1 plus L1 49 D2 plus 49 D1 W1 plus 49 squared D1 D2 equals to 1000. Further simplifying this, we then get 50 squared D1 D2 plus L1 50 D2 plus W1 50 D1 minus L1 49 D2 plus 49 D1 W1 plus 49 squared D1 D2 equals to 1000. L1 D2 plus W1 D1 equals to 10, as D1 D2 equals to 10. Correct? Figure this out. Let's go to A100 minus A90 now. A100 minus A90 equals to L100 W100 minus L90 W90. Let's sub this into this formula right here. We have L1 plus 99 D1 W1 plus 99 D2 minus L1 plus 89 D1 W1 plus 89 D2. Next step, 10 L1 D2 plus W1 D1 plus 99 squared minus 89 squared. 9 times squared minus 89 squared D1 D2. Difference of two squares we have over here. Further simplify this, we have 10 brackets 10 plus 99 minus 89, 99 plus 89 multiplied by D1 D2, as we figured out, was 10. We then get 100 plus 100, 99 plus 89. Final answer, write it over here, final answer, then gives me, putting it on the calculator, we get 18900. Question 6 done. Let's go on to question 7. Question 7. The number of 4-digit integers in the closed interval 2022 to 4822 formed by using the digits 0, 2, 3, 4, 6, 7 is what? Question 7. First thing I will do, 4-digit integers. 1, 2, 3, 4. Let's look at the first number, 2022. Obviously, it can't be lower than 2022. So we have 2022. 2. What are the options we can have over here? We can't have 0, but we can have 2, 3, 4, 6, and 7. So 5 different numbers. 5 is the first part. Next part. 2, 3, 4. We can have 2, 0. We can't have 2 or 0 here. We can have 3, 4, 6, or 7, which will be 4 other numbers, and 6. 4 times 6, 24. Next. 2, 3, 4. 2, correct? This time, we can't have 0 go there, but we can have 2, 3, 4, 6, or 7. Any of these integers can lie here. So 5 different ways. Obviously 6 and 6. 6 times 6 is 36 times 5, 180. Next, we have 3 and 6, 6, 6, relatively straightforward. 6 times 6 is 36 times 6 is 216. Lastly, 4, 4, 4, 8, 2. We can have 4, 0. We can have 4, 2. We can go 4, 3, and we can go 4, 4. So 4 different numbers can fit here. 6 and 6. 6 times 6 is 36 times 4 is 144. Therefore, n of integers can then be 5 plus 24 plus 180 plus 216 plus 144. Putting that in the calculator, final answer gives me 5, 6, 9 different ways. Question 7 done. Let's go on to question 8. Question 8. Let ABC be the triangle with AB equals to 1, AC equals to 3, and angle BAC equals to pi upon 2. If a circle of radius r greater than 0 touches the sides AB, AC, and also touches internally the circumcircle of the triangle ABC, then the value of r is what? Question 8. First thing I'll do is draw up a diagram just so that we can get our head around what we're trying to find. BAC is pi on 2, so let's just draw a right angled triangle. At 90 degrees, right here. A, B, C, B, A, C, 90 degrees. A circle joining this. Not the best of the drawings, but we'll make do for now. Correct. And a circumcircle inside, which approaches the triangle. Correct. C1. right here. This is C2, which is going to be R1, R2, and this is going to be 1 upon 2, 3 upon 2. Correct? Write that down. C1 equals to 1 upon 2, 3 upon 2, and C2 equals to R1, R2. Correct? R1, we know radius 1 is 10 upon 2. AB, the value of AB has been given, which is 1. AC is 3. 3 squared plus 1 squared root 10. R1 is halfway, root 10 upon 2. It's told us that C2 touches C1 internally. C2 touches C1 internally. Hence, C1, C2 equals to magnitude of R minus root 10 upon 2. Correct? This then gives me R minus 1 upon 2 all squared plus R minus 3 upon 2 all squared, which equals to R minus 10 upon 2 all squared. Expand simplifying, we then get R squared minus 2R upon 2 plus 1 upon 4. Expanding this, plus R squared minus 6R upon 2 plus 9 upon 4, which equals to R squared minus 2 root 10 R upon 2 plus 10 upon 4. Rearranging and simplifying, we then get R squared, 2R squared minus R squared is R squared. 10 upon 4 minus 10 upon 4 are gone. Have we made a mistake somewhere? That is R. Minus R minus 3R negative 4R plus root 10R equals to 0. Correct. Therefore, R either equals to 0 or R equals to 4 minus root 10. Because when we simplify this, factor out the R. Therefore, we've got a final value of R, which is 4 minus root 10. Question 8 done. Let's go to the next question. Section 2, max marks 24. This section contains 6 questions, multiple choice. Full marks you get 4, partial marks 3, and 0 marks 0, negative marks -2. Question 9. Consider the equation, this expression over here, alpha being an element of -infinity to 0 to 1 to positive infinity. Which of the following statements is /r true? Question 9. Let's rewrite the integral they've been given us. 1 to e. We have ln of x to the power of 1 upon 2 all upon x brackets alpha minus ln of x 3 upon 2 all squared dx equals to 1. Little substitution, let alpha equal to, sorry, not alpha, let t equal to alpha minus this inner expression here, ln of x to the power of 3 upon 2. Therefore, this then simplifies as ln of x to the power of 1 upon 2 all upon x dx equals to negative 2 upon 3 dt. Little differential equation stuff. Next step, let's rewrite this as 2 upon 3, rewriting the limits alpha minus 1, negative dt upon t squared, which equals to 2 upon 3, 1 upon t, alpha minus 1 upon alpha, equals to 1. Further simplifying it, we get 2 upon 3 alpha minus alpha, 3 alpha, brackets alpha minus 1, coming into this, equals to 1. Sort of substituting these values for t gives us this. Next step, simplifying this further, we get 3a squared minus 3a minus 2 equals to 0. 3a squared minus 3a, yep. Alpha then equals to 3 plus minus square root of 3 squared, which is 9, minus 4 minus 3, negative 12, 9 plus 24 gives me 33, all upon 2a, which is 6. Therefore, we've been given two values for alpha in this case. Looking at these options, we have an irrational number satisfies the above equation, more than one alpha satisfy the above equation. Therefore, C and D are our final solutions. An integer, no, because we've got two solutions. A and B are gone. Question 9 done. Let's go to question 10 now. Question 10. Let A1, A2, A3 be an AP with A1 equal to 7 and common difference D equal to 8. Let T1, T2, T3 ... be such that T1 equals to 3 and T n plus 1 minus T of n equals to A of n for n greater than or equal to 1. Then, which of the following is / are true? Let's write it down. T n plus 1 minus T of n equals to A of n for all n greater than or equal to 1. Next step, S of n then equals to T1 plus T2 plus T3 plus ... plus T of n minus 1 plus T of n, correct? Again, S of n equals to T1 plus T2 plus T3 plus ... plus T of n minus 1 plus T of n. Subtract top from bottom. We then get T of n then equals to T of 1 plus A of 1 plus A of 2 plus ... A of n minus 1. Correct? T of 1 we've been given equals to 3 plus n minus 1 brackets 4n minus 1. What we get when we simplify it. Further, let's expand this. Upon expansion, we get 4n squared minus n minus 5n plus 4. Correct? Writing it as a sum, n k equals to 1, we have T of k. T of k equals to 3. Apologies, 4. We have 4. Sum of n squared minus 4. Sum of n plus 4. Sub in T of 30, what do we get? T of 30, subbing that in to our calculator, we get 3, 4, 5, 4. Subbing in T of 20, we get 1504. T of 30 gives me 3454. T of 20 gives me 1504. Straight away, A gone. T looks promising. Coming back to this over here, let n equal to 20. We get k equals to 1. T of k should give me 10510. Correct. Looking at this, we get B. Therefore, B, C are our final answer. Question 10 done. Let's go to question 11. Let P1 and P2 be two planes given by P1, 10x plus 15y plus 12z minus 60 equals 0, and P2, negative 2x plus 5y plus 4z minus 20 equals 0. Which of the following straight lines can be an edge of some tetrahedron whose two faces lie on P1 and P2? Question 11. First thing I'll do is try and draw up a tetrahedron, just so that, again, we can understand what we're looking to find. Correct. A, B, C, and D, and then we can go line at the back. By observing these options over here, A is x minus 1 upon 0 equals to y minus 1 upon 0, which equals to z minus 1 upon 5. X and y having 0 in the denominator, meaning that they're parallel. Since we know that both x and y are parallel to the x and y axes, we can figure out, coming back to the first equation, per P of 1, let x and y equal to 1 because they're parallel. We can go 10 plus 15 plus 12z minus 60 equals to 0. Correct? Plus 60 minus 25, 12z equals to 35, z equals to 35 upon 12. Therefore, P1, the point of P1 gives me 1, 1, 35 upon 12. Correct? Do that for P2. Let's sub in x and y equal to 1. P2 equals to negative 2 plus 5 plus 4, z equals to 20. 15. 4z equals to 17. Z equals to 17 upon 4. Therefore, P2 then gives me 1, 1, 17 upon 4. These two values show me where P1 and P2 intersect. Correct? Line A, intersects with, at this point, with P1 and P2. Coming to B, we see there's no form of parallel connection with either of the lines. Same with C and same with D. So only line A shows connection with two given planes. But that doesn't mean that B, C, or D cannot be lying on P1 and P2, cannot be lying on the two faces, P1 and P2. Therefore, A, B, C, and D, all four of solutions are correct because it says can be an edge. Not saying it has to be or cannot be, it can be an edge. B, C, D don't give us enough information for us to dissect if they can lie on that. Hence, all four options are correct. Straightforward, question 11. Let's go to the next question now. Question 12. Let S be the reflection of a point Q with respect to the plane given by R equals to negative brackets T plus P I plus T of J plus 1 plus PK, where TP are real parameters and IJK are unit vectors along the three positive coordinate axes. If the position vector of Q and S are 10, 15, 20, and alpha, beta, gamma, respectively, then which of the following is/are true? Question 12. First thing, let's write down vector r equals to minus t minus p of I plus t of j plus 1 plus p of k. X, parametric equation, x equals negative t minus p, y equals to t, and z equals to 1 plus p. Rewrite t as y, so x equals to negative y minus z minus 1. Rearrange, we then get x plus y plus z equals to 1. Correct? Been given the value of q over here, 10, right in component form, 15, 20, and we have s equals to alpha, beta, gamma. Correct? In order to solve this, we're going to be using the line of reflection formula. Quick diagram, what I mean by that. Line of reflection formula. We have Q, 10I plus 15J plus 20K. Correct. Alpha, beta, gamma is up here, and x plus y, z equals to 1. Alpha plus beta plus gamma. J, K. Alpha minus 10 upon 1 equals to beta minus 15 upon 1 equals to gamma minus 20 upon 1 equals to negative 2. This is the line of direction formula. Line of reflection. 10 plus 15 plus 20 minus 1 all upon plus 1 plus 1. We then get separate each variables. 1 equals to 88 upon 3. When we simplify this, beta minus 15 equals to negative 88 upon 3, and gamma minus 20 equals to negative 88 upon 3. Therefore, alpha then equals to, add 10 to both sides, negative 58 upon 3. Beta equals to, add 15 to both sides, we get negative 43 upon 3. And gamma, add 20 to both sides, we get negative 28 upon 3. Correct? Now, let's sub these into this. Alpha plus beta, negative 58 upon 3 plus 43 upon 3, multiplied by 3, we get, we get A. Beta plus gamma, negative 43, 53, 63, 61, multiplied by 3, 71 multiplied, B is correct. And gamma plus alpha, 86, 33, gone, C. Therefore, A, B, C are the correct answers. D does not give us a final solution. Question 12 done. Let's go to next question. Question 13. Consider the parabola y squared equals to 4x. Let S be the focus of the parabola. A pair of tangents drawn to the parabola from point P, negative 2, 1, meet the parabola at P1 and P2. Let Q1 and Q2 be points on the lines SP1 and SP2 respectively, such that PQ1 is perpendicular to SP1 and PQ2 is perpendicular to SP2. Then, which of the following is/are true? Question 13. First thing I will do in order to solve this is draw up a diagram, plotting down all the information they've given us. We've got an xy plane. Y squared equals to 4x, so a sideways parabola looks something like this. Correct? Something like that. Yep. Next. Two tangents we have from point P up here. Tangent 1. Sorry, very bad drawing, but get the gist of it. Tangent 1, we'll say over here, point here, and we've got another tangent coming from this point up here. Correct, so this can be P1, P2. Next step I will do is draw point S over here. S be the focus of the parabola. So S can be somewhere over here. Point S, that is going to be 1, 0. This will be 4, 4. This will be 1, negative 2, and this is negative 2, 1. Next step, in order to solve this, is draw a dotted line through S, going to Q1. This will be Q1 over here. This is perpendicular to P, as it says over here. Q1, so PQ1, which is this line here, that is perpendicular to Q1, and PQ2 will be something similar to this line going up through there, joining PQ2. This is, in a way, perpendicular to that. Not the scale, sort of a diagram, but yeah. Now that we've found out this is PQ2, PQ2, let's come back to actually solving this question now. We know that T equals to y equals to mx plus b, mx plus 1 upon m in this case, which is the y-intercept. T passes through the points negative 2, 1, or in this case P, hence 1 equals to negative 2, m plus 1 upon m. Correct? Therefore, m either equals to -1 or m equals to 1 upon 2. Points then given by, we have a upon m squared, 2a upon m. 2a upon m. Correct? So, then we can go point 1 will then equal to four, and point 2 then equal to 1, -2, as we've demonstrated over here. P1s then equals to 4x minus 3y minus 4 equals to 0, and P2 of s equals to x minus 1 equals to 0. Correct? Hence, for more space, let's just draw like a little thing. P Q of 1 gives me magnitude of 4 multiplied by -2 minus 3 multiplied by 1 minus 4 all upon 5, which equals to 3. PQ of 1 equals to 3. Next, we're going to try and figure out S of P. S of P we already know is going to be root 10. S of P equals to root 10. So P Q of 2 then equals to 3. P Q of 2 equals to 3. We know S Q of 1 is going to equal to 1, which is going to be S Q of 2. S Q of 1 does not equal to 1, it equals to 2 over here, so A is not an option. A is not an option. Let's come back to this one over here. We have 1 upon 2 magnitude of Q1, Q2 all upon 2, Q1, Q2 all upon 2, plus root 10 equals to 1 upon 2 multiplied by 3 multiplied by 1. This is when we compare the areas of the two. So, next step, Q1, Q2, all upon 4 multiplied by root 10 equals to 3 upon 2. Q1, Q2 then equals to 12 upon 2 root 10. Further simplifying this, we get 6 upon root 10, which is going to be, further simplifying it, 6 root 10 upon 10, 6 root 10 upon 10, which is 3 root 10 upon 5, which is this one over here. Therefore, B, C, D are our final answers. Question 13 done. Let's go to question 14 now. Question 14. Let the magnitude of M denote the determinant of a square matrix M. Let G, 0 to pi 2, two real numbers be the function defined by G of theta equals to square root of f theta minus 1 plus square root of f pi upon 2 minus theta minus 1, where f theta equals to 2 matrix. Let P of x be a quadratic polynomial whose roots are the maximum and minimum values of the function g theta, and P of 2 equals to 2 minus root 2. Then, which of the following is/are true? Question 14. First thing I will do is simplify f theta, just so that helps us with g theta down the track. So f theta, write it down, equals to 1 upon 2. Write down this matrix. We have 1 minus sine theta and negative 1. Negative 1. Sine theta, we have 1. 1 over here, and negative sine theta, and then we have sine theta, and we have 1. Correct? And then I'll write this part over here. We have sine pi cos theta plus pi on 4 tan theta minus pi on 4 sine theta minus pi on 4 and cot theta plus pi on 4 negative cos pi on 2 and ln of pi on 4. And the last one, ln 4 on pi, we have tan of pi. Correct? Let's simplify the first part. This then equals to 1 upon 2. We have 2, 1, 1. We go 1, 1, 0. We have 0 sine theta, and negative sine theta. Boom. First one done. Let's look at the second one. Let's do it over here. We have sine theta, negative cos pi, sine pi, negative cos pi on 2, and tan of pi. All of that is going to give me 0. So we have 0, 0, and 0. Correct? Let's look at the other side now. We have tan theta minus pi on 4, negative cos pi on 2, already have 0, and cot theta plus pi on 4. This remains the same. Tan theta minus pi on 4. And this becomes negative tan theta minus pi on 4. Let's look at these ones now. We have sine theta minus pi on 4. It's going to stay. Theta minus pi on 4. The top would then become cos theta plus pi on 4 would become negative sine theta minus pi on 4. And then this one would become ln 4 upon pi. That's going to stay as ln 4 upon pi. Ln pi. And then the bottom one is going to be negative ln 4 upon pi. Boom. Done the matrix. By observing this, we know that f theta equals to 1 plus sine squared theta, as this is a skewed symmetric matrix. Skewed symmetric matrix. Therefore, coming back to this g theta, then equals to square root of 1 plus sine squared minus 1, this would give me magnitude of sine theta, plus magnitude of cos theta, which is an element of the restriction being given 0 to pi upon 2. G theta then equals to 1 root 2. Correct? 1 root 2. Let's come back to this part now. We know let p of x equal to k x minus root 2 multiplied by x minus 1. P of x would then give me 2 minus root 2 equals to k brackets 2 minus root 2, substituting x for 2, brackets 2 minus 1. 2 minus root 2 then equals to 2 minus root 2 then equals to 2k minus k root 2. 2k minus k root 2. Coming back over here, when p of 2 equals to 2 minus root 2, we know k equals to 1. When p of x equals to x minus root 2, x minus 1, k equals to also 1. Therefore, by observing these two values, when we sub in them individually into these, only A and C are correct. Therefore, A, C is our final answer for question 14. Now let's go on to the next question. Section 3, 4 questions, 4 matching list sets. One has multiple choice question, 2 lists, list 1, list 2. 4 options available. Let's get straight into it. Question 15. Consider the following lists. List 1 we have over here, and list 2 over here. The correct option is, okay, start with list 1I. Let's look at what I is telling us. It's saying x being an element of negative 2 pi upon 3 to 2 pi upon 3 with cos x plus sin x equals to 1. Let's write that down. So we have cos x plus sin x equals to 1. Multiply both sides by 1 upon root 2 cos x plus 1 upon root 2 sine x equals to 1 upon root 2. Further simplifying it, we get cos x minus pi on 4 equals to cos pi on 4. X minus pi on 4 equals to 2n pi plus pi upon 2, denoting that n is an element of z. With this in place, for x being an element of 0 to 2 pi, 0 to pi on 2, my bad, pi on 2, we know that only 2 solutions are possible. So for I, there's only 2 solutions going into it, correct? So since I has only 2 solutions, C and D straight away gone. Don't have to worry about C and D now. We know this only goes to, we've got II 333 and 444, all of the same one, so we don't have to worry about this. C and D is not right, so we only have to see if this goes to S or does it go to R, just to save time. In order to do that, we need to look at what sine x minus cos x equals to 1 gives us in terms of this restriction over here. Let's write it down. Sine x minus cos x equals to 1. This time we know cos x plus pi on 4 is going to equal to minus 1 on root 2, which is cos 3 pi on 4. With that in place, x plus pi on 4 equals to 2n pi plus 3 pi on 4. Again, for n being an element of z. Being an element of z. Hence, we know that x being an element, x being an element of, we get pi upon 2, negative 3 pi on 2, we have pi and negative pi. Therefore, giving us 4 solutions. With x giving us 4 solutions, it goes towards R. Therefore, B is the right answer. Straightforward question. Let's go to question 16. Question 16. 2 players, P1 and P2, play a game against each other. In every round of the game, each player rolls a fair die once, where the 6 faces of the die have 6 distinct numbers. Let X and Y denote the readings on the die rolled by P1 and P2, respectively. If X greater than Y, then P1 scores 5 points and P2 scores 0 points. Let's see what that means. We get P drawn in 1 round equals to 6 on 36, which is 1 upon 6. If X equals to Y, then each player scores 2 points, and if X less than Y, then P1 scores 0 points and P2 scores 5 points. Let XI and YI be the total scores of P1 and P2 respectively after playing the ith round. List 1, list 2. The correct option is what? So P drawn in 1 round is 6 on 36. P win in 1 round is going to be 1 upon 2 multiplied by 1 minus 1 upon 6. So 5 and 12. And P loss in one round would be 5 and 12. So winning 5 and 12, losing 1 round is also 5 upon 12. Let's come back to list 1 now. P of x2 greater than y2 equals to P 10, 0 plus P 7, 2. This gives me 5 on 12 multiplied by 5 on 12. 5 on 12 dot 5 on 12 plus 5 on 12 dot 1 upon 6 dot 2. Simplifying this, we get 45 on 144, which is 5 on 16. So Px2 greater than y2 is 5 upon 16. So Px2 greater than or equal to y2 would then be 1 minus 5 upon 16, which equals to 11 upon 16. Looking at the options over here, we have I goes to P, 3 upon 8, no. So C and D gone, 11 upon 16. So A and B are either of the options. Next one, we have II goes to, both of them go to R. Don't have to solve that. III, both of them go to T. Correct? IV is what we need to solve. IV is S, either S or T. So this was I. Let's go to IV again. So we have P, X of 3 greater than Y of 3. This is going to be equal to 1 upon 2, 1 minus the thing, T, 1 minus this. 77 up on 432. 2. Correct? Further simplifying this, putting that on the calculator, I believe the final answer should be 355 upon, we have 864. Observing the options, we get S. Therefore, B is not right, A is the correct answer. A is the right answer. Again, once we eliminate and actually try and see what we want to find, we can save a lot of time in the exam. So yeah, question 16 done. Question 17. Let P, Q, R be non-zero real numbers that are respectively the 10th, 100th, and 1000th terms of a harmonic progression. Consider the system of linear equations. X plus y plus z equals to 1, 10x plus 100y plus 1000z equals to 0, and qrx plus pry plus pqz equals to 0. List 1, list 2, the correct option is given. Okay. 17. Let's start with I. If Q upon R equals to 10, then we know A goes to D, which goes to dx, which goes to dy, which goes to dz, which equals to 0. So there are infinite number of solutions. Correct? Infinite number of solutions. we then know that x plus y plus z equals to 1. And from this over here, 10x plus 100y plus 1000z equals to 0. Coming back to this, we know that x plus 10y plus 100z equals to 0. Let z equal to a parameter lambda. X plus y equals to 1 minus lambda. X plus 10y equals to negative 100 lambda. Further simplifying this, x then equals to 10 upon 9 plus 10 lambda. Y equals to negative 1 upon 9 minus 11 lambda. Correct? So x, y, z then equals to 10 upon 9 plus 10 lambda, negative 1 upon 9 minus 11 lambda, and z lambda. Z equals to lambda. That is x, y, z. That is the case for x, y, z. We know that q, 10 upon 9, 1 upon 9, 0 is true for lambda equal to 0, and p, 0, 10 on 9, negative 1 on 9, not true for all lambda equal to 0. Sorry, for all lambda, not equal to 0, for all lambda. Therefore, I tends to go towards Q, R, and T. I goes to Q, it can go to R, or it can go to T. Therefore, all of these solutions could be possible for the first one. Let's go to II now. II, we can figure out over here if P upon R does not equal 100, as mentioned over here, then D of Y cannot equal to 0. So no solution for II. Therefore, II tends towards no solution S. In this case, so it's either B or D. A and C have been eliminated. B or D is either of our options. Let's go to III. We know that if P upon Q does not equal to 10, then D of Z cannot equal to 0. P upon Q cannot equal to 10, and D of Z cannot equal to 0. Therefore, I, no solution, tends towards S again, which in this case would be B is our final answer. We don't have to do the last one, so we've got it here. Question 17 done. Let's go to the final question now. Looking at the final question, in this paper, question 18. Consider the ellipse x squared upon 4 plus y squared upon 3 equals to 1. Let h, alpha 0, 0 less than alpha, which is less than 2, be a point. A straight line drawn through h parallel to the y-axis crosses the ellipse and its auxiliary circle at points E and F respectively in the first quadrant. The tangent to the ellipse at point E intersects the positive x-axis at point G. Suppose the straight line joining F and the origin makes an angle phi with the positive x-axis. List 1, list 2, the correct option is what? Okay, first thing I would do is draw up a diagram and see what this question is actually asking us. So we can draw up an ellipse right here. We can go a circle equation over here. Again, apologies for this terrible drawing, but we'll make do for now. O is the origin. We have point F goes over here. F, we have point G about here making a tangent. A tangent. Correct. Point F, point G. We know that H is somewhere underneath F in this case, which is alpha 0. And we have another circle here made up. Excuse the drawing, this is alpha, this is 0. H has been given. Phi, the angle being made, and we know that this is going to be 2. Now, coming to point F over here, this is going to equal to 2 cos phi, 2 sin phi. Let F be equal to 2 cos phi, as mentioned over here, 2 sin phi, and E be a point 2 cos phi again, root 3 sin phi. With that in place, we can rewrite EG then becomes x on 2 cos phi plus y on root 3 sin phi equals to 1. G then gives us 2 on cos phi, 0, and alpha equals to 2 cos phi. Therefore, angle F GH equals to 1 upon 2. We forgot this drawing up here. This line up here, my bad. Missed this line. We get 1 upon 2 GH dot FH in this case. point E is over here. This point E. GH, half GH multiplied by FH, which then equals to 1 upon 2. 2 upon cos phi, sorry, not theta, cos phi, minus 2 cos phi multiplied by sine phi. This then gives me f of phi, which is 2 tan phi. When we simplify this, 2 tan phi sine squared phi. Therefore, coming back to this equation now, we know that f of pi on 4, when we simplify and we substitute pi on 4 into this, our final solution should be 1. Coming back to A, B, C, or D, A and B, I tends to go to R, which is incorrect. So A and B are gone, C and D are the options. Let's do I now. This tends to go for F pi upon 3. When we simplify that into this, we should get 3 upon 2, 3 upon 2, looking at my calculator, 3 upon 2 multiplied by root 3, which would be 3 root 3 upon 2. Looking at this, tends to go to T, therefore our final answer is C. Final question done. Thank you guys so much for watching the video. Your love and support helps this channel a ton. If this helped you in any sort of way, please leave a like and please subscribe. Other than that, I'll see you in the next video.